Okay, welcome back. So in this video, I want us to write the code that does the merging, the ordering and merging of the values. So let's call our function merge, and this function will take a left value and the right value. Then it will return the sorted values. So for example, if it gets 1 and 2, if it gets the left being 7 and the right being 5, then it will switch it to make sure it's 5, 7, and then it will return that as a slice. Okay, so it returns a slice with the ordered values. Okay, so all I'm going to do, I'm going to first create the slice that I will put the ordered values in. So I'm going to say merged. We use the make function. We want to make a slice that will hold ints. Okay, and the slice, it will have 0 elements, so the length is 0. And the slice can be as big as the length of left plus the length of right. So it cannot be any bigger than this. Okay, so it has to be bigger than left and it has to be bigger than right. Okay, so int. Yeah. Okay. So once we have merge, merge will contain our result that it will send back. It will take the left value and the right value. All right, but keep in mind that they're still considered a slice. Even if it's just one item in the slice, it's still a slice. Okay. So even though I say the left value and the right value, I mean the left slice and the right slice. Okay, so once I do have that, I'm just going to create a loop. Okay, I'm going to loop and order the values. Okay, so I'm going to say once we have something in left, okay, so once the length of left is greater than 0, there's something there, or the length of right has something in there, okay, greater than 0. So once we have things in our left and things in our right, or things in our right, then we can continue ordering. So the first thing I'm going to do, I'm going to check to see if the length of left is 0. Now, if the length of left is 0, then that simply means that I only have the right to deal with. And so what I'm going to do, I'm going to simply return, okay, I'm going to call append, and I'm going to take merged, okay, and I'm going to add to merge the right. Okay, okay, the 3 dots simply means take what is in the right slice, right? So if I have like 1, 2, 4, whatever, I will have to, the dot means take them out and add them into the merge slice. Okay, so I'm not adding the 2 slices together. I'm taking what is in right and putting it into merged. That's what that means, right? Sort of unpack. All right, so it means I will take the right and put them into my merged. Okay, now if my left is not empty, then let's do the same and let's check to see if the right is empty. Okay. So if the right is 0, it simply means that I will return I will return append but merged, but I will instead use left. Okay, I will use left. Oops, else if. Okay, oops, else if. Yeah. Okay, so that's what I'm gonna do. Now, if that's not the case, then I have to do another else if. So now they have something in them, right? And we know that it's just two values. Just two values. So I'm gonna check left 0 because that's all there is. And if 0 is less than right 0, since it only has one item, okay? So if the left is greater than the right, then I know that it's already ordered, okay? And so all I'm gonna do, okay, if left is less than right, I'm just gonna put them in, right? I'm gonna say merged is merged with left 0. So I'm just gonna put left 0 into my slice. And once I do that, then I want to remove that item I added to the merge slice. And so left, and this is a pattern right here to get everything other than the first thing. Okay, so left 0 was the first thing. Left 1 colon means everything else, if there is anything. All right, so that's the next case. Now, obviously, if that's not the case, then the last thing we can do, or that is to be done, would be merged is simply append merge to right, because it means that the right 0. Okay? It means that the right was greater than the left. Okay, and then of course we will simply say right is right 1 colon. Okay, and then when we exit this loop, okay, we will end up with merged containing the ordered and merged slice. So again, let's take, for example, end up with let's say 3 for the left, 2 for the right. Okay, because remember, you call merge after you have done left and right. Okay, but remember, when you call merge and you have something that has, like, let's say 4 values, okay, then you're basically going to call merge again, and merge is going to keep calling itself until you end up with single values. So let's assume that you end up with single values, and so finally we can call merge. So let's say those two single values are 3 and 2. And so now I will create my slice merged, which will hold my answer. And remember, my answer should be 2, 3. That should be my answer. And so now I'm going to check. I'm going to say once length has something in it, left has something in it, or right has something in it. Yeah, it's true, right? Left has something. So we don't even need to check this one. Okay, it has something. Now, is it 0? Is it empty? No. Is it empty? Is right empty? No. Now, is left, is left 0, 3, less than right 0? No, it's greater than. So we're not going to do the else if. So what we're going to end up doing is to say, okay, I'm going to take right 0, which is 2, and I'm going to put that into merged. All right. And so I'm going to say right now is going to be right everything else. But then it means that right will now be empty. All right. There's nothing else, so it's empty. 0. Length 0. And so after the first loop, we're going to come back. Is length left greater than 0? Yeah, left has something in it, 3. Okay. So because it has something in it, we can continue with the loop. So I'm going to check, is left 0? No, it's not. Is right 0? Yes, it is. So if right is 0, it means I'll just take the 3 and put it at the end. And so that's what I do. I take the left, which is 3, and I just put it at the end. Okay, so now merged has 2 and 3. And then I will continue the loop, because remember, only one of these will ever be executed. Either the if, the else if, the else if, or the else. Okay, and then of course I come back. Where are we? Oh yeah, and then I remove the 1 from the left. So left now has nothing in it. Okay. Okay. So left has nothing in it. So both of them are empty slices. And so I'll check. Is the length of left greater than 0? Nope. Is the right of length greater than 0? Nope. What it means, I have done my ordering. And so I will simply exit the for loop, which drops me to line 25. And so I will return to 3. And so this 2 and 3 will be returned to whoever called it. And we know that who called it is from merge sort. All right, from merge sort. Okay, so that's how you do the merging. Let me remove this here. So you do the merging. Okay, and so to check that this actually works, we're gonna run it. So go run main.go, not run main.go. Okay, so we get 7, 11 minus 1, 4, 9, 0. And if it's sorted, it should be negative 1, 0, 4, 7, 9, 11. So that works. So let me just save it. So git add everything, then git commit message implemented the basic merge sort. Okay, great. So we have our merge sort completed. It works. And so in the next lesson, I want us to speed it up. Okay, and so I will show you how we can use Go routines and channels to actually speed up the merge sort. And what I want you to think of is the fact that we're calling left and we're calling right. Okay, so in order to get the right, we have to wait until merge sort has completed on left. Okay, but there are two things. If this merge sort spends a minute getting the final values, then this one here on line 35 will have to wait a minute. Okay, but wouldn't it be nice if you say, okay, you know what, merge sort, I'll make you be a Go routine. Go do your thing. Okay, what does that mean? It means that we can have the next merge sort being run. So if this one is in its own Go routine, and we make this one into its own Go routine, it means that right doesn't have to wait for left anymore. They can both be running concurrently. All right, so we see what that looks like in the next lesson. I'll see you then.